In this video, I will give you an overview of big data analytics. So there are three terms here: big data and analytics. We'll try to understand what we mean by these three terms. We'll first talk about analytics, next we will talk about data, and then we'll talk about the word big. So let's talk about analytics. And before we talk about analytics in the context of data, we will talk about processing in the context of data and analysis in the context of data. So there's data processing, data analysis, and data analytics. So what's data processing? Now traditionally, we had raw transaction data like financial data, sales data, inventory data, marketing data. And we performed some data processing using computers, and we converted the data into information like reports. And using those reports, some managerial decisions were made. And as we progressed, we started dealing not just with transaction data, but all kinds of data. So survey data, customer data, employee data, payroll data, marketing data. And we performed data analysis, which produced not just information, but also knowledge. And by knowledge, we mean relationships between variables. And using both information and knowledge, managerial decisions were made. So these decisions were of a better quality than the decisions made just from information without knowledge. Now, data analytics emerged when we started having big data. And of course, we'll talk about what makes data big in future slides in this video. So when we have big data and we perform analytics on big data, we get information, knowledge, and even insights, which is like a higher degree of knowledge. And we make decisions and take actions based on information, knowledge, and insights. There have been two major developments in the last 20 years due to which we have big data analytics. One is that we have a lot more data today than in the past, and mainly because a lot of data today is generated automatically. And two, storage costs have declined tremendously in the last 20 years. And the second development is that there's a lot more computing power available today than 20 years ago. So these two factors have allowed data analysis of finer granularity possible. So let's talk about granularity, coarse versus fine granularity. So a very coarse granularity would be total annual sales of the company, just one number. A less coarse data would be total annual sales of the company broken by categories of product. Now, even finer granularity will be total annual sales broken by not just category of products, but each product in each category. Even finer, break it down further by country. Even finer, break it down by each month. Even finer, break it down by each store. Even finer, break it down by each day, in addition to category, each product, each country, each month, each store, each day. And you can keep going, by the hour. So each time we make the granularity finer, we are collecting more and more data. The volume of data is getting higher. Now, let's take a step back and talk about the word analysis versus analytics. What are some dictionary definitions? So, Oxford English Dictionary, analysis is the resolution or breaking up of anything complex into various simple elements, the opposite of synthesis. Now, same dictionary, analytics is a systematic computational analysis of data or statistics, or information resulting from systematic analysis of data or statistics. So notice that the word data did not appear in the definition of analysis, whereas the word data appears in both these definitions of analytics. Webster Dictionary analysis, a detailed examination of anything complex in order to understand its nature, to determine its essential features, a thorough study. Separation of whole into its component parts. Statement of such an examination. Again, the word data does not appear here. Analytics, the method of logical analysis. So here, although the word data is not here, the word logical has appeared, which did not appear here. That doesn't mean that this analysis can be illogical, but the stress in analytics on logical, which sort of indirectly refers to data. Dictionary.com, the separating of any material or abstract entity into its constituent elements. The science of logical analysis, information resulting from systematic analysis of data or statistics. So again, the stress is on logical and on data. So this term analysis is a very generic term. Analysis does not refer to data analysis. So what about data analysis versus data analytics? So it seems that the word analytics, even if I don't add the word data there, it refers to data analytics. So by default, the word analytics is basically data analytics, whereas the word analysis by default is not just data analysis, it's a very broader term. So what about data analysis versus data analytics? So data analytics is a relatively new term. So I can tell you my personal experience. I started hearing this term around 2010. Around 2010, it started becoming popular. Popular enough that I started hearing about it. So that's only 15 years ago. So in the context of the history of the word analytics is a very newly born baby, just a couple days old, if that. So there is no clear differentiation between the definitions of data analysis and data analytics. To me, data analytics is basically more detailed or finer granularity data analysis. Now, before 15 years, when I first started hearing the word analytics, I was teaching statistics using data. And I used to tell statistics is the science of analysis of data. So basically, they're the same. It's just that we are now dealing with much more data, more granular, finer granularity data. So there's nothing fundamentally different about data analysis and data analytics. Now, we first talked about analysis versus analytics, then we talked about data analysis versus data analytics. What about business analysis versus business analytics? Now, business analysis is evaluation/assessment of a business to determine its weaknesses, strengths, threats, and opportunities to help enable changes to its practices to increase its value. So notice the word data did not appear in this definition of business analysis. Business analytics, describing a business through data and reporting and predicting the future performance of the business through predictive models and insights. So here the stress is on data and prediction and insights. So both business analysis and analytics aim to improve value. They have some common ground. In general, business analytics focuses more on data, whereas business analysis focuses more on business processes, business systems, and business operations. All right, so let's talk about types of analytics. Descriptive analytics, systematic description of what is based on data. So techniques such as pivot tables, pivot charts, infographics, etc. are used to describe the business. Diagnostic analytics, a form of advanced analytics that examines data or content to answer the question, why did it happen? Predictive analytics, systematic development of models to predict the future. Predictive models are built using historical data. Prescriptive analytics, systematically generating optimal decisions and actions to be taken in the future, justified by numerical analysis of predictive models and other considerations. Cognitive analytics, a combination of AI and data analytics, which enables analytic tools to think like humans. Now, when analytics first emerged, we talked about three types: descriptive, predictive, and prescriptive. Diagnostic analytics and cognitive analytics are relatively new terms. Now, analytics for various business functions: marketing analytics, financial analytics, accounting analytics, operational analytics, social media analytics, web analytics, and so on. Marketing analytics is systematic analysis of various marketing issues. For example, study of consumer response to a specific promotion program, study of consumer behavior to any number of marketing parameters such as price, quality, promotion, distribution, social media presence, online presence, etc. Study of sales data by region, by store, by product category, by time of day, year, by salesperson, etc. Financial analytics, a systematic analysis of various financial issues, systematic study of equity markets using fine granularity data, obviously. Study of bond markets using fine granularity data. Study of financials of a company. Study of the effect of one country's financial markets on another country's, etc. Accounting analytics, a systematic analysis of various accounting issues, a systematic analysis of expenses and revenues, again, fine granularity, expenses and revenues. Analysis of direct and indirect costs, analysis of variances of costs with respect to budgets, analysis of cash flows. Operational analytics, a systematic analysis of various issues related to operations, studying the efficiency of operations, identifying bottlenecks in operations, studying the quality metrics of operations, studying how lean the operations are. Supply chain analytics is part of operational analytics. Social media analytics, there's so much social media data being collected. So, systematic analysis of the activities on social media. Frequency and duration of visits, frequency of posts, likes, shares, comments, types of things liked and shares by individuals, types of groups followed by individuals, number of friends and connections, identifying subscribers for target marketing, trends, etc. Web analytics, a systematic analysis of web traffic, clickstream data analysis, identifying the effectiveness of online advertisement for a product. Study of user demographics for visitors for each website, frequency and duration of visits to each website, etc. Okay, so now let's talk about what's the big in big data. So there's 5 V's of big data: volume, velocity, variety, veracity, and value. Volume. There's nothing to explain. Volume is just volume. And what is interesting is how the volume of all data in the world has grown in the last 15 years. So from 2010, we had only 2 zettabytes of data. What's a zettabyte? We will see that in the next slide. And now 2025, we have almost 180 zettabytes of data. And that's the source of this graph. So how is volume measured? So 1 byte is 1 character. 1000 bytes is a kilobyte, so 1000 characters. 1000 kilobytes is a megabyte. 1000 megabytes is a gigabyte. Giga in Latin just means giant. 1000 gigabytes is a terabyte. Tera in Greek means monster. 1000 terabytes is a petabyte. Pente in Greek means 5. So 1000 to the power of 5. 1000 petabytes is an exabytes. Exa is like hexa, which means 6, so 1000 to the power of 6. 1000 exabyte is a zettabyte. That's what we saw in the previous slide on the graph. 1000 zettabytes is a yottabyte. 1000 yottabytes will be a brontobytes. We don't have that much data yet. In spite of all the data that we have in the world, we don't yet have brontobytes of data. And 1000 brontobytes will be sometime in the future geop bytes. And that's the source of this information. So how big is a yottabyte? So a terabyte can fit on a hard drive on your computer. A petabyte would fit on a cabinet in a data center. An exabyte would fit in a 4-story building that takes up a city block. And a zettabyte will fill 1,000 such data centers. And if we have 1,000 such data centers, it will take up 20% of Manhattan. And a yottabyte would require 1,000,000 such data centers. And 1,000,000 data centers can fill the entire states of Delaware and Rhode Island. Velocity is the second V of big data. So a lot of data is now collected automatically through machines like satellites, telescopes, sensors, devices such as flight data recorder. A lot of mobile data is collected automatically. Clickstream data is collected automatically. A lot of social media data is collected automatically. So here's a picture of velocity every minute of the day. Now this is 4 years ago. Every minute of the day on Facebook, 44 million views happened. Again, this is 4 years ago. 240,000 photos were shared. On Instagram, 65,000 photos were shared. I'm sure by now it's a lot more. I could not find a more recent data like this. And so on. Variety. Now in the past, we just had quantitative and qualitative data, structured data of rows and columns. But now, in addition to structured data of rows and columns with quantitative and qualitative data, even text data is now considered data. In the past, text was never considered data. Now, email is data. Customer reviews or any type of reviews are data. Social media posts, even the text and the images are considered data. Tweets, messages, documents, considered data. Images is also considered data. Audio is considered data. Video is also considered data now. Veracity. Veracity refers to the quality and accuracy of data. Veracity refers to the level of trust there is in the collected data. Now, I believe veracity is a desired characteristic of all data, big or small. I don't believe veracity makes data big. It's just that because we have so much data now that veracity comes into question. We have so much data, how much do we believe in? And there's all issues about fact checking because there's so much data. We don't know what's the source of the data. Is it propaganda? Is it trustworthy data? So veracity plays a bigger role in big data than it did in small data. When we had small data, the sources of data were reliable. Only organizations with some checks and bounds created data. But now every individual is creating data. Every individual with all kinds of agenda is creating data, and it's hard to tell information from propaganda. So veracity has become a lot more important of an issue with big data, but veracity was a characteristic of small data as well. So that's why in the literature, veracity is listed as one of the characteristics of big data. Value. Now, value refers to the value that big data provides. Again, I personally believe that there's value in every data set, not necessarily a requirement for data to be considered big. Now, here's the thing. Although value lies in every data set, the bigger the data gets, the more the value is hidden. So, extracting value from big data becomes important, and extracting value depends on the skill of the data analyst or the data scientist. A skilled data scientist can extract the hidden value better than an unskilled data analyst. And as a data analytics professional, you will add value to society, to an organization, by skillfully extracting hidden value in data. So in this course, we will develop some skills to extract hidden value in big data. So big data. So back in the day, computers were big and expensive, memory was expensive, data collection was manual, data collection was expensive. almost all data was structured and fit in rows and columns. Number of rows and columns were limited. There was no text data or image data or audio or video data. We had small data. But today, computers are much smaller and cheaper. Memory is much cheaper. Data collection has become automated. Data collection has become much cheaper. We have a lot of structured data, and the number of rows and columns have increased to millions or hundreds of millions or even billions of rows. There is text data, image data, audio data, video data. We have big data. So that's the end of this video.